Hello Internet. Today we're going to build a stock market prediction model from scratch using GPT4 and the new Gemini model, which comes free on Bard as of the making of this video, late December 2023. Maybe there's something better out now, but we're only going to rely on these two chatbots to build the model, and I think we're going to build one of the most cutting-edge models. It'll be yet to be determined whether this is going to be something that will enable you to retire. It's always a bit of work, a bit of a slippery task to predict stocks. So I think this is something that's on the right track, although I can't promise it's going to be something that is immediately going to get you gains right out of the box. But let's get started on that. First, let me go to the cloud service provider I'm using. Of course, if you have a GPU at home or you have your own cloud service provider, if you're using Google, Azure, Amazon, they all offer these things. But I'm going to be using Stratomus Cloud Computing, which I think offers some GPUs at some pretty good rates if you're inclined, but you can skip to the section of the video. I'll put the time right around here for when the building of the model begins. But I'm just going to take a little time here to set up the GPU for anyone who would like to follow along with that part. So, just already registered there. Going to log in and enter my card. And I'll talk a bit more about using predictive models in the stock market, why that might be something, if you haven't tried before, you might be picturing computer says stock goes up, put all your money into the stock going up. That's not exactly how things work. Typically, even the best models, which probably only work sometimes, end up being something that maybe work 52% of the time. And when you're losing that much, you can't have a period of time where you're making double or nothing bets over and over again. So if you were to use a model to start betting in the stock market, you should have about 15 different stocks. So when you put money on a stock, it should be 1/15 of your entire bankroll to keep a losing streak from completely wiping you out, blowing out your balance. Also, you'd want to have an equal amount long and equal amount short. That would mean betting $1,000 worth of stock would go down, betting $1,000 worth of stock would go up. That way, when something unpredictable happens to the market, then you would be shielded from that. Robinhood does not allow you to go short. Webull, I believe, is the most popular platform that lets you go short. So those two things, 1/15 of your bankroll and equal amount long and short if you do this. And of course, I think a model like this, you'll see it when we get to it. I'll be describing it as we get there. I think it is very good. I think it's on the right track of building something like an artificial brain. But let me talk about what I'm doing here on the screen. We got logged in here to our cloud service provider. The cloud service provider you're using is probably going to need you to paste in your SSH key. This is my public SSH key. You'll have one. If you're on Linux or Windows, you copy this line, you open a terminal, and you get this public key. This is just some encryption on your machine that you want to copy and paste and put on the machine that you are renting so that you will be the only one who will be able to log in. So paste that there, add that, and it's going to take a bit of time to build that VM. And while that is building, why don't we talk to GPT4? So we will have to install some dependencies. We'll have to bring in the data and then process the data, which always ends up being more code than you might think it would be. Just preparing it, normalizing it, putting in some indicators, and then converting it to tensors and putting it into batches and segments. So that's going to be what we'll get to as soon as we're set up. But as far as the model, GPT-4, the reason it works so well, according to the rumor mill, is that it's something called a mixture of expert model. So if you know what a neural network is, that will be somewhat required for you to not be lost during this video, to have a general sense of what a neural network is and at least how to build one in PyTorch or get ChatGPT to build a simple feed-forward network in PyTorch. So a mixture of expert models has several different models within it, and then the predictions that these different models are making are what's called gated. So the different models within the model, in other words, the experts we're calling models, those are basically going to focus on different parts of the data. They're going to have their own opinions and their own knowledge. Those are going to go through a gating mechanism. So we're going to use several of those. We're going to put those into a multi-head transformer. Multi-head attention block. Actually not a transformer. These are a lot of words to juggle. But so we're going to have three. In fact, let me just draw it out. Anyway, I'm really all over the place. This is typically what a neural network is in its more basic sense. Linear layer forward goes into this nonlinear layer called rectified linear units. A more complicated name than it needs to be. It just turns everything that is a negative number into a zero. Everything that's a positive number remains that same number. It's just a process. You're putting the information, the function through. Well, it is a function, but then when the computation goes through that, and then it goes to a linear function where things are multiplied and you get what the multiplication is. And then that goes backwards with calculus, the chain rule, in order to update. Reward strengthens certain neurons that got the prediction right and reduced neurons that got the prediction wrong. So there's going to be one of those, and then the mixture of expert model will be, let me pull this up here. It's going to be several of these, several networks within, and in our case, we're going to do 3 mixture of expert models. There's one mixture of expert model, There's the second mixture of experts model. So then we have 9 neural networks in this first part. And then this is going to be for a multi-head attention mechanism. A lot of jargon, a lot of terms. They'll really be intimidating, but to learn these things, really it just takes a few days of, let me move this, just a few days of looking at these networks and working them out, putting them through your notebook and seeing what the math is doing, what the shapes are doing through each part. So you'll just plug this in. We'll get to our Jupyter notebook, it's called, pretty soon. You'll just implement this and then see what it's doing at every step. You can print out what the input is at each part of this, and this would be where it trains, it's called, like I was talking about earlier, where the prediction and the actual are computed into an error or the loss, and then that gradient updates the neurons, strengthens the ones that were right, reduces the ones that were wrong, and updates that. That happens over and over. So really not that hard to wrap your mind around, especially after you look at it on a very small, granular, close-up look, and you just spend a few days with it. First learn to crawl, learn to stand up, learn to walk before you try to run. But back to our model we're going to build here pretty soon after we process the data. So these are 3 mixture of expert models, they're called. These 3 things are all one of those feed-forward networks. Then they have a gating mechanism to make the best predictions go through. So these different networks, these 9 networks, could specialize in different things. And then for a multi-head attention mechanism, the input is queries, keys, and values. So we're going to have 3 distinct ones that's going to go through the multi-head attention, and we'll get to that as well. Also something that is very cutting edge, and you can look at a lot of moon rune, complicated math on the topic. But when you look at it and you get GPT4 to produce the most simplified version it can, while still being a multi-head attention, it's really not so tricky. It's just a bit like learning a few phrases, learning enough phrases in Japanese to get around. So, moving on with our model, the output of that multi-head attention, it's going to go into another mixture of expert model, and then the output of this will be our set of predictions. And the input, let me make sure you can see, yes. The input is going to be a tensor. This would be the batch size. So there are 512 things in a batch that have a answer we want out of the network, whether the network will make a prediction on each one and it'll find out when it's right after it outputs a single value, in our case, for each batch. But the input is going to be a batch of segments, time series segments. Let's say they're going to be of length 60. So if we were doing days, it would be 60 days that the market was open, that we would have the closing price each day, and then the number of stocks is going to be something like 260. So this is called a tensor, and this is what's going to contain our data. We're going to put our stock market data into this form. If you're not used to this, tensors and matrices, to break it down for you, hopefully, to make it a little more simplified. I know the word matrix can really throw you. Just think back to your high school math, whether you did or did not get this far in math class. If you know miles per hour, then these would be the hours, these would be the miles. But let's say you went 2 miles in 4 hours. Actually, let's make this. You'll see where I'm going with this here in a moment. If you see I'm writing there, 4, 2. There we go. So just answering the question, what is a matrix? What was that thing I was drawing there in red? It's pretty simple. It's all this, comes out of this Cartesian coordinate system, which is what calculus was built on. But this 4 and this 2, this is just another matrix. And what does the 4 and the 2 mean? It means that we have the 4 here on this part of the graph. So that means 4 and that means 2. So that's what the 4 and the 2 represent. And then the let's get rid of this. Bear with me here, I'm juggling a few things. So that's what that's as simplest form of a tensor or a matrix or matrices. We're going to be multiplying different matrices, transposing matrices. So don't freak out. That's about as complicated as they are, but they just build from those. And we're still waiting for the machine. Okay, machine is ready. If you can see that, now that our machine is done on Stratamus, link in the description below, we have this IP address, and you'll copy this, it's saying login as root. So let's do that. And this is going to, I typed yes there. Now we're in this remote machine. See here if we have our GPU with NVIDIA SMI, and as of the time of this video being recorded, CUDA version 12.2 works with the pip install PyTorch. By that I mean you can install PyTorch like this. Okay. If that doesn't work for you, if you can't do a pip install, first let me install pip before I get ahead of myself. But if that doesn't let you install with just that simple install instruction, you might need to go hunting for the Python PyTorch version that works with CUDA 12.2. It's an eternal struggle between the CUDA, the NVIDIA driver, the CUDA version, and having a PyTorch version that works seamlessly so that you can use the GPU. Pip install torch. And then that's going to take a little time as well. And like I said, I hope if you don't need a GPU setup and you have PyTorch ready in your Jupyter notebook, which we'll get to that as well, that you've skipped to the time and I'm not wasting your time. But let me go back to my drawing. Let's see. Get rid of this. So the thing we're going to make today, this mixture of experts, and these tensors, matrices are just as simple as what I spoke about before. Miles per hour, how many miles did you go, how many hours did it take, and you can represent that in a matrix. That's what these are. These networks can get very large. You can have a lot of neurons and layers built up, and then you get into different dimensions. The math, the calculus works in those different dimensions. That's why people don't quite know why a neural net knows what it knows, and there's so much fear about the interpretability and AI safety, but specifically about our model, why I think this would be good and why I think this is a valuable path to pursue, whether it's just a hobby, whether you really want to be a quant doing machine learning and AI, maybe you want to do this for a job, do something, some modification of this, put it in your, whatever reason you're doing this. I think this is pretty interesting that this kind of thing is emerging. The rumor, like I said, was that GPT 3.5 and 4 were using one of these mixture models. Why you can feel understood by GPT 3.5 and 4 and these large models tend to know what you're talking about and get this context is because of these mixture models that I think it being somebody with a brain like yourself makes sense that this is something that we're getting to building intelligence, building a brain, that it would have these different contexts within it. Like you have different sequences memorized and different sequences that work in different ways. Like you might not know how to, which finger presses the E key, but you know that in a context. So I would think of these different neuron pathways, like the neurons, the way that synapses form in our brains, that it's probably something like this, that we have different ones that we call on, like if you're being pulled over or by a cop, or you're in a job interview, or you're encountering a wild animal, these different sequences kick in, these different neural pathways. So I think we're getting there towards something. And of course also these large language models use transformers. We're not using a transformer today, but we are using attention, which is the working part of the transformer. The transformer is basically the network being aware of itself, self-attention, paying attention to what it's paying attention to, focusing on different parts. And that's what this part is here, where the three mixture of network models meet. and then they come out here. So I think it would be this hierarchy, and I really think, like I was just saying, that you need to learn to crawl, learn to stand, learn to walk, and learning a new language, learn the alphabet, learn the most used phrases. So there tends to be this hierarchy in learning and in intelligence, and then this self-attention. Yeah, that's why I'm making this video, why I think it's something worth doing. And I have asked Bard and GPT4, since I really wouldn't know how to search all the papers if someone is stacked. That's what you might do, what I would call, what I'm doing here is stacking the experts, right? Like, sort of like the layers are stacked within a neural network. You have one layer after another. That stacking, in other words, taking the output from one mixture model and using that as the input for a new mixture model. Whether that's being done. So, like I said, I've heard that many of these large language models are mixture models, but I think it's pretty much on the cutting edge that people are using attention and stacking mixture models. Let me ask Bart, has anyone stacked mixture of expert models with multi-head attention in between? Do you know of this in industry or in any papers? Let's ask Bard. Let's ask GPT4. Not widespread. So someone has done this in 2023. Huh. 2021. Dynamic routing. Mixture of experts with multi-head attention. So it looks like this is the only one that's stacked, taking the output from one, using that as the input for another. Risk of overfitting. And I hope I've given my disclaimers for your hopes, just to taper your expectations that you might be driving a Lambo later this week. It's something where you're going to climb a mountain, and then you're going to see another much larger mountain once you reach the summit of this mountain of just processing the data and building the network. Overfitting is a big problem with neural networks in time series prediction. So we're going to try to overcome that. We're going to try to use some dropout, L1 and L2 regularization. But looks like our terminal's done. Let's do the test here. Python 3, import, torch. Okay. Interesting warning, whenever you see some warning or error, failed to initialize. Although we do have CUDA. This is always what you want to see. If you have false, then bad news for you, but we do have true. I wonder what this error is exactly. Probably it says the CPU. We definitely don't want to use PyTorch on the CPU. That warning or error is not worth exploring as long as you see CUDA is true. Then let's go to our Jupyter notebook. And this is how you're going to get Jupyter running on your remote machine so that you can control it through your browser. Run a Jupyter Notebook instance through your browser on this machine, in other words. Hope I'm being clear enough. Jupyter Notebook should not be installed. I think you don't want to do either of these. Let's try this. Sudo apt-get install Jupyter. What else can I tell you? How to get back to our Jupyter notebook. Copy that, paste that in here. I think I want to just try 8095. Pressing enter. Okay. They don't recommend using root since we're on this machine in a virtual environment. I will use root. If you don't want to use root, you can look up. DigitalOcean has a good article on it about how to create a new user in Linux if you don't know how, but I'm just going to use root. If you're using some sensitive data, you know, hospital patient data, I don't know what to tell you, but so we're going to need that. We're going to copy that into our browser. But before we do that, the other step will be to open a new terminal locally. Just to be clear, this terminal we've been using here, this one is on our machine that we're renting in the cloud on Stratomus. So this is that machine. It's now running a Jupyter notebook with this encryption here, ready for our browser. But what we want to do on our machine, on the machine that you have running locally, you want to open another browser. And let me pull that up in the screen record. And then you want to run the second command. SSH, capital L, 8095. And the remote user is root. And then coming back to that remote machine. It's going to be that IP address. Copy that. So this is actually going to log you in as if it wants you to do something further on that machine, but you don't. You just minimize this, and then going back to this other machine remotely, we're going to copy and paste that into our browser, and then we'll have a Jupyter notebook. And there we go. What you want to do is go to New, Python 3, and you'll do, let me do this example for NumPy. Throughout the course of this video, there's going to be a few cases where I'm going to do an import like this. If you get an error, because I have an environment already set up, but when you see this error, no module named NumPy, that second terminal I just talked about minimizing, which is open to the remote machine, what you'll do, thank you for your patience if you already know this, but what you'll do is to go in there and do, in most cases, pip install, and then the name of that thing you tried to import. Then that should install it, and next time you go to import it, it's going to be there for you. Import torch, just because you love to see it. Double check. We have CUDA again. Okay. So we're ready to get to it. And in order to train the model, we're going to train it on some slightly older data. Then we're going to download the newer data, the newer stock prices, and see how the model trained on that older data does on the newer data. This is something where you usually would use a training set, validation set, test set, but this is going to be something really contingent on visual inspection with the human eye. So we're just going to train on this older data and then look at the newer data. And in the description of this video, there is a file with this name. This is our old data, and let's talk about how you can see that. Bringing this in, we're going to be relying heavily on a package called Pandas. Oh yeah, let me move that. Anyway, in your case, after you download this, Anyway, when you get the link to where this CSV is stored, you're going to want to download it on that window we talked about minimizing. That will go in the root here of your remote machine, and you won't have the problem that I have. So just let me grab this. So, yeah, we have a file called the notebook, which ends in IPYNB. That's your Jupyter notebook here. So we just want that CSV to be in the root in that same file as your notebook. And then that's going to allow you to do pd.read, which is pandas, the CSV file, which is just a spreadsheet, something with rows and columns. This is what it looks like now. These were the actual prices. And this is 5-minute data. Here's what ALL and all these other stocks were on 9:30 and then 9:35 and so on. And this data is for 2 months. It's almost 3,300 rows. And what we're going to need to do next is some processing of the data. Let's first, like I said, we're going to be relying on GPT4 pretty heavily. So what we want to do, always be paranoid, looking for something to spoil a pot and wreck the data. So how to check and get rid of zeros and man values in a CSV in pandas. So we don't want it just because the market didn't, the Yahoo API might not have had it that day. We don't want it reporting that the stock was zero, especially because after we normalize it, that's going to show up as some certain specific value. We don't want the model to think that that stock went to that value one day and then went right back. The count of nans in each column. Let's do this check first. We'll be doing a little bit of checking, quite a little bit of checking, a little bit of redundancy. Redundancy doesn't hurt. So this df old, our data frame, is na.sum. If 0 what's the most descriptive thing to call this? I'm going to try to make everything I name as descriptive as possible. So we're going to look, since this doesn't tell us enough, we're going to loop through it and see if we have more than one zero in a column. A little confusing because it says of the ones that it did show, there are 0 zeros. And then we looped through it to see if there was anything that was not a 0. So there were no zeros in any of our data, which you'll see sometimes. All right. Was that 0 or NA? We need to make sure to check for both. Drop NA. Use a condition. Right. Sorry, I misspoke there. It's not checking for possible zeros, it was checking for possible NA before. That's what I should have named it. NA or NaN, which will turn all the output of the model into NaN. So another thing you need to watch out for. I wonder if I can iterate through this. Okay, but if we do have a 0, what should we do with it? I agree, it's more appropriate to replace, as it says here at the bottom, replace a NaN value or a 0 instead of removing it. So let's do this. Let's replace NaN and zeros with the value in the cell above. Even though we don't know, and even though it looks like we don't have any NaN values or zeros, we still want to get rid of them if there are any hiding. Because that second search was not really clear. It's the last value, zeros. And you think it's going to be fun to work with AI, but it's plenty of tedious spreadsheet work. 80–90% of it preparing the data, really just making sure there's nothing in it that's going to torpedo the model. Okay. Don't need that. We're going to keep these for later. Okay, what else do we need? What is the Does pandas have a built-in way of doing this to each column? So mean of 0, average of 0 for all the values in the time series, and then to reduce the variation down to a standard deviation of 1 to make all of the time series uniform in this way. That way the model can know that just because the AutoZone stock is at 3,000 and the Ford stock is at 400, that things are normalized. There's more to it than that. There's more to it to help the model, but we don't want to have huge values in one place, small values in another place, just because of the price of the stock. So we asked it how to normalize, and it's really giving us a lot of options here. It looks like standard deviation of 1, standardize each column, and then there is a choice. You can do the normalization, the applying of the mean of 0 and standard deviation of 1 to the whole entire spreadsheet, to all of the values. So that would make some of the values have a higher standard deviation of 1 or a higher or lower mean than 0, just to balance out this other column over there, which might have another value. But for these different time series, we're going to make it so each of 1 is more or less equal in the eyes of the model for the price changes. And that's still going to allow it to observe the relationships between the stocks. And that reminds me, I didn't get to that. Maybe I'll talk about it the next time. We're a little slow waiting on some process, but you should ask yourself why your model should work. Why do you deserve to get paid by the market? Well, you need to come to the market with something that's more intelligent. More intelligent people get paid by the market, because when you set the price and you provide liquidity, that is, you're doing more buying and selling for the market will reward you if you bring in some special insight. So what we're trying to do, although the odds are always against us, and it's more of a hobby than anything, if we can bring the market something like this, and we're looking at all of these stock relationships, we can bring in some insight. We can exploit an inefficiency in the market. The market wants to be more efficient. The market will reward you for being more efficient. Although it's a bit of a, that's the value you would bring. Like I said earlier, it's a good hobby, and then this model can probably be applied to some easier tasks for your industrial or creative purposes. Something that's not a zero-sum game like the stock market. That is, someone having to win in order for someone needing to lose for somebody else to win. But I do digress. Thank you for indulging. if this is worthwhile. This looks like a good way to normalize. And, oh, okay. NP is not defined. Import NumPy as NP. NumPy math library. Ooh, okay, of course. That didn't work. So it ended up that our dates here, our times more specifically. We want to make that the column. Sorry, not the column. It is a column. We want to make this column the index. Oh, interesting. Pretty sure there was a way to do that. I know there's a different function called, sorry if you couldn't see that, set index in place. In fact, let's run this from the beginning. Okay. So when we imported it, date time was just another name of a column. We set that to the index and then had to delete the old column called date time. Then we normalized it. Now it should have a mean of 0 and standard deviation of 1. So every one of these, I don't know that I pointed it out, 261 columns are different stocks. The time series values that started from September 7th, 2023, extended till November 3rd, 2023. What else would help the model learn and make a good prediction? Time embeddings. Whether you're doing this for stock market or any time series value, let's talk about time embeddings. We'll see what they are here in one moment. Write a function to create time embedding columns to my data frame. My data, my time series data is in 5-minute increments. So do an embedding for 5-minute, hour, day, week, and whatever increments you think would be helpful to have. And can we talk about GPT-4? How much better it is? Whether you did any Python programming before you saw this video or before ChatGPT came out, this is like having rocket skates. This model does all of these things you could do, you could learn how to do, but it's very fast, very insightful. So I don't think I need year. That's interesting. Weekend, part of the day. I don't think I want those either. No, I think just this will do. Let's try it. Thank you for the notes. Date time column is going to be the index. None of index. I found an index. What if the index was a list? Nope. In the columns. None of are in the columns. Well, maybe we'll work around that by putting that issue we just had with normalization and the date column and index after. And we'll bring it back in straight from the CSV file. And since that column is still there, we're not going to delete it till later. Try passing that as the date time column. None of index are in the columns. What does GPT-4 think about this error? Specified key column name is not found. So just the column names. Just the column name as a string. Oh, that's how they wrote it. Okay. I see. They already had the name of the column being indexed by the data frame, so we didn't need the data frame being indexed here, just the name of it. Now we can delete that column and do the normalization, which we did before, but then we went back to the CSV to do this workaround. What do we have at the end? It's our embeddings, time embeddings. Good to do a little work to the data, a little working on it, just to let the model know, because rather than giving this information to the model and trying to get it to figure out what these different values are, every 5-minute increment is denoted with a value, and so on, day of the week, month. So these have their values, and these are also normalized with a mean of 0 and standard deviation of 1. So that order worked out for us. I forgot I did want those embeddings normalized as well. Okay, so that's our data pipeline. I think it's ready to turn into tensors and turn into batches. And probably not necessary to copy and paste in here, but let's make it obvious for GPT-4. My data is ready to be converted to tensors and to a training set. I will not be needing a test or validation set. I would just like the data converted to tensors and a data set. I want the batches to be in the form sequence length and features. Let's do a batch size of 256. Sequence length for X of 60 and a sequence length for Y of 22. Please and thank you. This code is for a rocket launch, so please do your best. Thank you so much. I've heard if you tell it please and thank you, and that the code is very important, that it will give you a better answer, but it usually gives me a pretty good answer regardless. Sure, we'll need those imports. They're called. We have Torch, but we need tensor data set and data loader. So scroll back up. Oh, I'm sorry if you haven't been able to see that up there, but you can see it now. So this is what it's telling us. Torch tensor values. Interesting. Really? Okay. Yeah, so it's going to look at all of our values, convert them to a torch tensor 32, sequence length 60, see if we get an error. This will be our data loader we'll use here in a moment. Might be due to memory constraints, no. I know I should know how to do this. I used to know, but I don't really do it as often as I should. And then now that we have ChatGPT, which is like spell check, who needs to know when you have not spell check, but the did you mean? Oh dear. What? Convert all columns to numeric. non-convertible values to NAND. That doesn't sound good. I don't want to drop NAND or zeros. There are any. Just write a class to convert the time, convert the data to tensors with a different approach. We might have to go to Bard for this one. What does Bard say? Come on, Bard. Data point. See, that's a different approach. See what kind of error this gives us. What if that's a class? Did it mean data? Data is not defined. That's true. Oh dear. What? Are these not the exact same words? You know, I recently updated Jupyter Notebook and it's a little off. Okay. Well, Oh yes, I needed to import that, of course. This is a case where getting sloppy is really starting to eat up a lot of time. You know, you try to be lazy, coast, and let it do the work, and then you end up getting in a loop like this. And we're still getting that same error, so there must be something like a nan or 0 in here, but I thought we got rid of those right here. Was a new one introduced in some way? We're going to be at our model pretty soon. Almost there. That'll be the interesting part. I'm still getting this error, even though I thought I got rid of all zeros and nans with the code below. What am I missing? Still contains non-numeric data types. Requires data to be in a uniform. That's interesting. What will this tell us? Float 64. I mean, we have stock data, we have time embeddings. There shouldn't be any other value that got in there. Does it have a problem with float 64? Which is good. Still might be some. Like I said, in the start of this data cleaning process, you should assume there's some bad parts in there. And it looks like there really were. Oh God. This is that kind of error with no obvious solution. Print the shape and type of df old values. See if there's anything unusual. Like what? This is the kind of error somehow I've never encountered with these updates. Something changes sometimes. Tell me everything I can possibly do to remedy this. What can I check or apply to the data? Non-numeric. There we go. Brute force fine comb. I don't think we've tried this coerce yet. Okay, whatever was in coerce worked. We're going to need to keep this as part of our process. We will need this later for the new data. We're going to want to process it the same way. Clean things up a little bit. Put everything we need to process the data into this one cell. And that coerce thing didn't seem to do anything weird. All the values are still intact. And it looks like it gave us a data loader. We have that. So this is going to return some samples which are not shuffled, so it's going to go in sequential order. And I hope I've been paranoid enough talking about the NaN numbers, talking about the possible zero values in there, watching out for anything that might torpedo the whole project. When training, you might also want to do a shuffle equals true, so the model is getting input samples that are shuffled, just to make sure that you're not getting leakage. I think it's called leakage, where the prediction and the actual has been given away somewhere in the prediction to the training data, because we have two tensors here, matrices, arrays, two tensors. Let's look at the shape of the first one. And the shape of the second one. So the first one, as I showed, it's 5-minute increments. It started at 9:30, 9:35, 9:40, 9:45. 60 of those time increments. Those go right up until 61. And they end here in the X. This is called the X, and this is called the Y. And then it's going to try to guess something about the Y. We'll get into that later, but it's going to try to guess something. That guess is going to be called Y hat. If you're going to be doing this as a hobby or more than a hobby, and you don't know, you're going to learn X, Y, and Y hat pretty well. Like I said, you don't want the Y to seep in any way to the X, because then the Y hat will not be a true prediction. It's going to be cheating. It's going to be a cheated prediction. And then when it gets to data that it hasn't seen before, it's not going to be generalized. Almost as bad as a problem as overfitting, although overfitting is much easier to do. Once you've overfit, you've learned the answers to the test. You just have all the answers memorized to the test. You have the order of the answers memorized because of some homonym or something, that you write those answers, but then when you encounter the thing in the real world that the test was about, you can't generalize what you learned in the class, learned on the test, in order to apply to that situation. That's overfitting. And yeah, I hope you're not too advanced into machine learning and that this stuff is interesting for you. If you are pretty advanced, you're probably someone who spent the last 5 or 10 years learning this stuff the hard way, and now here I come with GPT4 showing the kids how to do this stuff. Like we just, for example, fixed this problem here in the data by using something. I'll be honest with you, I don't really understand what happened there, and I didn't need to dig deep. So it's like this stuff is putting you on a higher layer of abstraction, you call it. Like, I don't pull oil out of the ground or refine gasoline. I don't know how to fix my car. I can kind of tell when something's going wrong with it, but those layers of abstraction, it is, I think, something to be taken advantage of, that you have these layers of abstraction here, that you can use them and move along. Anyway, have I explained that? This is the X, this is the Y, where this sequence ends, and this is a sequence. These are 256 sequences of 60. You have 60 sequences for all 267 time series. Those would be the columns. There's 267 of these, counting the time embeddings. So those are what each of these are. And then these stop at 60, and then 61, 62, 63 is 20, 21, I'm sorry, 61, 62, 63 is 0, 1, 2, and 3 until you get up to 82, the 82nd value in that sample of the time series that it took. So, like I was just talking about, layers of abstraction, but you want to keep your head in the game, being aware of what these things are, because we're going to reshape them, we're going to move them, and we're going to want to get to, or you want to get to a point where you're familiar and always aware, and not totally leave it as a black box, because the model could make a mistake and be doing something strange, treating one of these as time, as values in the sequence. So, as a matter of fact, maybe we should do something to check. Yeah. Let's plot something out before we get to the model. Why don't we? For x, y, in loader. For y, for values in y, append, let's put this in a list, y list, append the values, and we have this, it's the shape of this, so we just took every y value, I believe, if we did, it should be of a certain length, not shape. 3192 minus 60, that looks right. What do these look like? Okay, they're not in batches. We're getting 22 of them. Yeah. We're getting 22 of them. We don't want 22 of them. We just want one of them. As I said, this was the y value. This is the continuation where the x value stops. And this is the kind of fluency you want to have with these, with your data, even though it's turned into a tensor. If you want to train the AI networks, do something interesting, you should be fluent with the tensors and what's in them in order to keep a handle on them, make sure nothing funky is happening to them. And why I'm doing this, you'll see here in a moment. Let's index a specific one of these stocks and chart it out. Have a chart of it made, and then we'll see what the chart looks like in this data frame, and then we'll see what the chart looks like after it's gone through all of this. As we said, we talked about abstraction layers and things being a black book. I don't quite remember what is in here, what exactly is happening with all this. I mean, I generally know it's going to try not to. It's doing this so that it doesn't sample from something. It's adding and subtracting the sample length so that it doesn't try to grab something from outside of this value. But even if you did write that and understand what all of that was, that's the thing about logic, is you think you understand it until you find out you don't really understand it. So let's plot both. Let's plot the before and after. Please write me a function to plot a chart in matplot for a column in a data frame. Also, in another function, write something that plots although are these even tensors anymore? Oh yes, it is. I think we might just need it to plot to print, create, respond with one thing in a data frame. Probably use that for both purposes. So if we just do is that it? Yes. I think that'll plot just like our column will plot. Although we don't want to plot the 0th element here. We're going to plot something else. What do we have for a plot? Okay. I know you came here to get a model, see the model, see how well it works, but this is responsible. Oh yeah, you might need to do that. I'm working on a computer that already has that installed, but like I said, with this new packages, and we brought in quite a few. When you're getting that error, no such package, you bring up that thing we talked about minimizing, which I can pull it up in the terminal here somewhere. Maybe. Yeah, that other one we minimized, not this one, but the other one. And you do pip install name of the package, which if you don't have it, you're going to have to do with this pip install matplotlib for this step. And we're going to import that. And let's plot this. Although, let's get our index for the stock we want to print out. It's Adobe 0, 1, 2, 3, 4. And that's going to be for in list, which is at the 4 index. This isn't right. We do want that to index, but we want a 4th element. Will this work? Okay. And then I believe this stock is our Adobe. Let's see if that prints. Oh dear. We don't need this as a function. Did I tell it to write a function? Oh, shouldn't have done that. Okay, column name, plot, plot, label, label. We don't need this. Column name. And remember we talked about counting to 4 in the column is 4. We're going to do another way of checking that. Always as much redundancy as possible. Columns. I think this should be a list. Index. Dot index. So by doing this, we're able to enter any ticker into our df column here. Any ticker, whether you know it's in there or not. Oh, as a matter of fact, I didn't talk about how we know. Because it doesn't show all 260 or some values, the way you return that as a list is what I just did here. That'll give you all those symbols. And like I said, you can index it here. We also have the DIA, which is an index fund of the Dow Jones. That'll return this number. It's the 67th. So not only do we use this to know what numbers in our column, but coming back to this guy here, we know that Adobe is 4, but we could have got DIA with 67, although it says Adobe. Let's just call it stock. And this should be a stock array of DIA. And then with df of DIA in one plot over here. Of course, we don't have a df named df. So we hopefully have one plot here. Maybe, just maybe. While that's cooking, we should have another plot here in stock array. I've never seen it take this much time. So possibly another one in stock array here. So, like I said, what we're testing out is the data. We can even pull it from a separate most original source. We have source totally unprocessed. Okay, yes, because the column, even though we didn't process that one, we still want to delete a column called date time so that it matches the one that we processed. Okay, now it's exactly like the old one with the most minimal processing. I had to get rid of that column. So this is a good way of checking. That is 67, and then we'll do this instead. And the thing that we're pulling from the Y list, the Y list is out of the data loader. The data loader came from here. The data loader, you know. Now, the reason I'm being so redundant is you always want to triangulate things, look for a problem that you don't even think exists, just to keep double checking, because we're using more and more abstraction the more we rely on this. Okay? Almost done. So that's what we have for the original data pulled from the CSV. And then this is what we have from the tensor. So that looks good. Even though these are values up in the 300s, the shapes are still going to be the same. Okay. What can we delete? All right. Now we're going to get to the model. This data is ready to train on, and the model is going to be this mixture of experts model. Yes, where was I? So, data is processed. I can't believe that took almost 2 hours. Yeah. So we're ready to start the model, and of course we'll go ask GPT4 please write a mixture of models, export in PyTorch. Please set the number of experts to 3. Creating a mixture of experts. Model in PyTorch involves defining a set of expert neural networks and a gating network. The gating network determines the weight with which each expert's output contributes to the final output. Below is a basic implementation of an MOE with 3 experts. The gating network defines the weight with which each expert contributes to the final output. So there's the expert. As I said, if you were watching during the setup of the environment, it's a very simple network. And there's the gate. Let's see where they put this. Gating network, which is just a linear layer of its own. And this is too many classes. But that is where they're using the gating network. And it actually goes through this gating network first before it goes to the experts, the expert networks. So output 0, like zeros. Okay. Combine expert outputs. Interesting. So your input goes in here through this forward and runs through each of the networks in this list comprehension. Interesting. These are too many classes. Please integrate this into the mixture of experts class. Please. So this is expert 1. I say it's expert 1 because we're going to have another expert. Expert mid as in not the end. So we're going to stack the experts. We're going to have the output of one expert go through a multi-head attention and then go become the input to another network, this one here. And dimension will be reduced, but we will put a few more layers on this one. And then we'll really have to test to make sure things are not overfitting, but we'll cross that bridge. How's our mixture of expert class? With the gate integrated, see, that looks better. Yeah, it's just one line. So you have to keep an eye on this thing. Yep, got those. Sorry, I hope that's big enough. Our expert for we're going to have 3 of these experts, but this expert mid will be this network, and then the second one, expert end here, will be this one, this network here. And maybe I'll go over this again when we're doing some training, when there's some free time. Talk about why I think this is worthwhile. Interesting hobby in the least, for something to work on. Okay. Self-experts. Where is it bringing in the expert? What? Oh, it brought the whole thing. Of course. We put the whole thing together, even though we have separate classes for these number of experts. Number of experts would be 3. We will define input, hidden, output. Input size will be I believe it would be feature length. So here are our networks. We're just focusing on this one for now. And we're going to put this into the, you could call this the handler or the builder of a single mixture of experts. It handles all 3 of these and puts the gating mechanism on it. So we're going to define it in the init init. What should we make? The output size, I want it to compress a bit and continue compressing as it goes through our stacked layers. Starts at about 260, 270, and let's just say it'll go down by 1/3, which would be about 80. Okay. Our input size will be the length of our columns. That is the number of not only stocks, but time embeddings. These would be the columns. It's our input size. That actually goes right here in the network and right here. Hidden size, let's just make that 200, 3 experts. Control Shift minus to split this cell off of this cell. Expert is not defined. Where is it looking for an expert? Oh, of course. To change the name of the superclass. The super. Sorry, I don't even know what that's called. The super. That object is not iterable. Yeah. You know, the whole thing about list comprehension and loops of models, I feel like this started with when the transformers got popular. It's not like the old days. Experts. It's a module list and a number of experts. So let's make a list. For in range, number of experts. And try that on another line. No, it wouldn't be iterable. Would it? Expert outputs. I guess I don't quite get it. Okay, a little closer. 1, 2 were given. Expert mid. Input hidden output. Takes one positional argument, but 2 were given. Oh, this should work outside. Input, hidden, output. Okay. Why would this not work in a list? Is it the module? Oh, of course. Module list. That was, you know, you can watch someone code where they have the code off screen, or hopefully you're skipping around if you're too bored seeing someone do this on the fly. So that's our MOE model, torch random. Where is our X? Three must match size of a tensor. Gating. Input hidden. Three experts. You know what this is. $267. So the gate why does the gate need it has an output of 3. What was our output size? Is 5. We should be able to change that. Number of experts. But it was able to pass. Okay. This is made for a 2D tensor. Sure, I could rewrite it for a 3D tensor, but we do have GPT4. You know, seeing me stumble over this simple stuff, it's good if you're 12 years old. If you've never never worked with this stuff because I'm going so slowly, having problems on things that are so simple. It must be easy to learn. Better than, I mean, you don't want to see somebody flying through this stuff at a pace where you can barely understand what's happening. Okay, I put that network back in. The gate is the same. Now it's getting some different sizes. Looks like only the forward function changed. All right, and that's a good output. So as it went through, or will go through, the output will be 80. So we can even change that. Five 12, 60, 80. Why did I do that? Because intelligence is compression. So it's just going to press, and intelligence will pop out. Kind of mimicking the way that neural networks work themselves. They tend to go from, I mean, even as the GPT4 wrote it, these input sizes, hidden size, and output size. Input size, hidden size, then the output size is smaller than the input size. Really, like I said, really a channel, a video for the kids so that you can really learn. Great time to learn, great time to get in. Where was I? Okay, now we have one of these. We've created just this one, but we want to bundle them and have three. So let's think about how to do that. Where could I keep this? Just off to the, there we go. The way to have a bundle. Triple mixture of experts. That, we don't need that. And before, when I was struggling on this part, I just wrote module instead of module list. Why not just put it in a list, just store this as the list comprehension it's called in here. It's because when you do this, PyTorch knows to apply the behind the scenes neural network neuron stuff. Backpropagation, the chain rule, the things that we don't manually have to deal with. Okay. How would I bundle three experts? I don't want to put any new gating mechanism on it. I just want to make a new larger network. So could basically call this, basically copy and modify it. triple expert network yes. Maybe I should do the attention. I'll do the attention after this. Just get this started. So what are we going to need? We're going to need to define 3 of these. Number of experts. Yeah. A gate. We're not going to need a gate. We're going to want something like this. MOEs, plural. And let's put not 3 networks, but 3 of these. That should work. And then what would the forward be? We're going to put the X through the same X input, that tensor we talked about, this one here, which is the same tensor here, the 2 tensor. So this is our input, batch size, sequence length, number of columns. Every single one of those is going to get copied 9 times, put in here, 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 and here. So when we're doing triple the 3 networks, we want to put all 3 of those through. Probably overthinking it. Expert. We don't need to modify the shape. The lower network will do that. But we do want the X to come through. MOE, expert outputs. You don't need to do this twice. It's happening above. Experts. Yes. Should I rename it? Even though we're not dealing with experts, we're dealing with number of networks. Yeah. Num-mos. We do need to keep this to pass through. Okay. Number of expert outputs. Let's get rid of, wait. Yes. Let's just see what this does. Triple Mo, triple network. And number mixtures of experts. Probably should have made, well, I had to make the outputs, I had to have 3 networks, but maybe I should have just done 2 in there to make it more obvious, less confusing. Because now we have 3 of one thing below and 3 of another thing. Maybe that'll be a challenge for you if you want to modify the number of layers. Actually, that'd probably be pretty simple to do. Okay, how do we do an input to that? Int object not iterable, of course. For the numbers in range, MOEs. Self. Modules missing forward function. There's the forward. What is missing the forward function? That's the input. It's going through all of these. What about this is missing a forward? What? I'm missing the required forward function in MOEs. Oh. I see what I did there. Did I? Well, no. Maybe I don't know. MOEs. Okay. So I need to extract from here, run the X through these in this list. We already know. Module list, number of experts. The number of mo's goes here. We don't need this. And I don't want to iterate these in a range. Okay, we're getting a shape as the output. We have three things in the output. What do we have in item number 1? Okay. So in this output, this looks good. This will be our query key and value. If you want to see, it is that's not what we wanted. Okay, there's three things that triple out. They are of the output shape. One output for this. Oh my gosh. I'm sorry about that. Had that covered up. Okay. Had a slight disconnection there. What ended up being the issue was I was trying to iterate through this object. And this is not something that the X goes through. This is something that we need to run through, pull the objects out of this module list, and then extract here. We don't need these. So now the number of experts here, number of modes, we don't need that because we don't need it below. There's the output. And then this network here, this has our output of our query key and value for our multi-head attention. So this class, triple expert network, contains all three of these, which contain 9 networks. Spins up three of these, and then one of these spins up 3 of these. Before we use this, we will get a multi-head attention together. Let me move this. So write a multi-head attention mechanism. Write a minimal implementation and do so in PyTorch. Make it with 4 heads and set up for a 3D tensor of batch size, sequence length, features, persuasion. Of the batch size, sequence length, features, persuasion. Requires implementing core components for the attention mechanism, scaled dot product attention, and then extending it to support multiple heads. Below is a simplified implementation. The reason that towards the end of 2000 teens, in the beginning, 2020, 2021, if you're following machine learning, especially before GPT-3 came out, you would see people talking about AGI being a generation away, at least 20 or 30 years. But the reason we have GPT-4 in these large language models as good as they are is because of this attention mechanism, which is essentially a way to get more computations done in parallel. I don't know if I like this. What is this? Where does it get this bad code? I mean, it's not bad, it's just extra. It's too much. This multiplies. Okay. This handles the attention. And sounds pretty exotic. What is a query? What's the key? What is it querying? What's the key to value? It's just the same. The same tensor. This one actually multiplied by this one, scaled a little bit, and then multiplied by this one. And it enables it to have self-attention, to be aware of what it is aware of. I don't know that it would create stocks, perfect stock predictions. In fact, it's more likely to overfit something you're going to have to keep an eye on, work at definitely. Let's see. Sorry, let me move that. So I've copied these two. I like separate things, and we don't need them. Let's see if I can compress. Yeah. Mask. Oh no. We don't want the mask. There's a mask. No mask. Okay. Not going to get into what a mask is, but we don't need it. Bed size. Dense. I'm just checking this. It's a bit hard to check out loud, especially because I don't know, should I compare and contrast it to another one? Scale attention scores, query size. Alright. It's going to scale it by that last dimension, the last feature, or the feature, which will be 80. So it's going to do a square root and scale that. As a matter of fact, I could pull up the equation for attention. This is the one case probably where the math is simpler than the code and the terminology. You know, this is all it is. Oh dear. Yeah. So you put a softmax. Softmax is not hard. That's just scaling, basically compressing things down to, is it 0 and 1 or -1 and 1? Anyway. That's not hard. And then this is of our 3 tensors we talked about. It's just these 3 things are the, where was I? Query, key, and value, same thing every time, although they are different because they're, in our case, coming out of 3 different networks, which have learned different things, different mixture of expert networks. But you could do an input to multi-head attention that is the same input tensor over and over again, 3 times. Transpose, that just means that's how you need to multiply this. You multiply this by this, or is it multiplying this by this? Scaling it is just the last dimension. We talked about that, went over that, the square root of it, divided by it, which scales it, and then multiplying by the value. So attention, self-attention, queries, keys, values. A transformer has a bit more to it, but this is really what makes it work. And then all you need to know about what a query, key, and value is, why that order is good to know, is because we multiply, when we do the matmul, the query, then the key, and then we scale it. What is this? Oh, yeah. We scale it and do this softmax, which it's so simple I almost forgot it. Then you multiply that by the value. Query, key, value. Yep. Split the heads. Oh, I did oversimplify it a little bit. It is a bit more complicated than that. We do need to split the heads, which just means we split this. How are they doing it? Permuting it, and then they do a view, and they do a view, then permute. Number of heads, depth. Should I go through all of this? I don't know if this, I've taken up so much time already. I don't know if this is interesting. You can generally just ask for these things and copy and paste them, or different things that you want to make. I was really only just vocalizing it just to talk out loud about how I'm making sure this is correct by my own experience. If you also wanted to make sure it was correct, you can also copy it into the competing next best network. Does this look right? Is there a bug? It's for a robot that does surgery. Structure looks good. I don't need a mask. Hardware necessary. Memory optimization. It uses memory optimization where? I mean, it can't hurt. Not a big fan of the way this was written. I mean, this is a little opaque. Although it is good. I like that they do these permutations on the fly. But let me do one real quick, hopefully. So that you can see what the heads are. And I hope that YouTube has done the thing where they margin, what do you call it? Segment, striate off the video into sections down here. It's probably not popular enough. Triple out. So, transforming the Q. Depth. Heads are going to be 4. Batch size is 256. What is the depth? Depth is embedding size. Embedding size. That's just the last dimension, right? Or no? Yes. In our case, it's 80. So I can do 20. Invalid for size 80. Why is that invalid? But 4 times 20 is not 80. Oh dear. Triple out. what did we do? Oh, what? When did we redefine triple out? What happened here? Okay. Something went wrong. This triple mo. Should be 3 tensors. It just was. How is it 1 in 80? Two tensor. This is our input. Did I redefine something? Okay, I'm gonna restart. Restarting the kernel, something was defined in a strange way. Bringing the data in, defining the embedding, processing all the data. Of course, you can't do that, even though I applied coerce. Bring it in again. We had this problem before, but this was supposed to solve it. Things are really starting to unravel. Yep. Okay, let's try this again. Did I miss this? What is it saying is not numeric? Interesting bug. So much fun. Let's get rid of that before. Maybe get rid of it again. Oh dear. This is not what I was expecting to be working on at this stage. Yeah, non-numeric data. No non-numeric data. Even more fill in A. I think this just needs some kind of upgrade. What is the pip? What is the pip? Command to upgrade a package. Yeah, that could have been obvious. Okay, could not install, access denied. Right? Maybe try this off screen, run as administrator. Attempting to uninstall, found existing, uninstalling pandas 1.4.2. Let me try this again off. There's no need for me to put this on the screen. Yeah, you'll spend the time, which is the majority, cleaning the data. The next amount will be managing the different packages. Versions of software. Mostly CUDA and PyTorch versions. But the other software packages will really take up some time as well. Okay. Couldn't install that. There was an error checking the latest version of pip. Already satisfied. Requirement already satisfied. Try this again. What fill-in method is depreciated? Object fill. Oh, so would that mean, was this our issue? Maybe. Fill. Yeah. Although a NAND doesn't usually prevent you from creating a data frame. Converting that to tensors, usually it goes right through and then the model will just end up outputting NA, and then you find out what the problem is. Okay. Probably need to import this again. And I have low hopes for this one. Yeah, you get a bad package. What could it be? Bard is more up to date. Maybe Bard knows. There's no non-numeric data in my DF. Should I install a previous version of pandas? This is pandas 2.1.4. Do you know about this bug? Can't convert in the array of type numpy object. What is the numpy object it is talking about? Maybe it's because of our embeddings, but this is a new problem. I've been doing this for a few years. And with this CSV itself, in a previous version of Pandas, and I didn't have this issue. Okay. Did we see that? Whatever this was. It seems to have fixed it, although it seemed like we fixed it before, and everything that fixed it the last time didn't work this time. So let's just keep that. Good to have this. Now that we need it in this block, which we will use again when we need to convert the new data we get. Okay, we don't need that. That was fun. And what was our problem with that tensor was coming back as 80. 1 and 80. That was strange. Are we going to get that again? We have the model of models. I don't think that's defined. We took that out of the data. I took that out of the data loader. Output is not defined. Right. Yeah, I must have. Just have to restart the kernel sometimes. Different definitions get mixed up and make their way into the classes, into the functions. Okay, that's good. That's good. What were we doing? So, looking at what a multi-head attention does to the Q, K, and V tensors before they are input. Well, the thing that gives them their multiple heads is this reshaping. This object has no view. So it's just a bit of reshaping because what was our original tensor size? If you want to be real specific, it was this one here. So because 256, 60, and 80, because 80 divided by 4 is 20, we're dividing it by 4 because we have 4 heads of our attention mechanism. And then that gets permuted we switch this with this dimension here and here. And if you really want to think about it and dig into it, I've spent enough time with the exposition, but reshaping them, permuting them, is what is the 4 heads. It's what computes the attention. Okay? And this looks good. And after it is multiplied, the queries times the value, scaled, softmax. Did I say value? The queries and keys, scaled, softmax, multiplied times the value. It goes through a final layer, and that final layer connects things, concatenates, as it calls it here. I don't know if that's the right, I don't know if I like that word for this purpose. We don't need that. Less is more, less is better. Dense net. Okay, multi-head. Let's try this with our output. For those, it's going to be 80. And we have 3 of these, so I suppose the input might work like this. Oh yeah, missing 2 positional. Query and key. Let's be explicit. Query, key value, in, key value 4. Valid syntax. You know, I've never done that before. Missing 2 positional arguments. Okay, doesn't like that. Doesn't like any shenanigans, nothing fancy. The 0th, the first, the second. Query is not defined. Of course not. We copied it, took it out of a function. Input must be tensor, not integer. Tensor, not integer. But it is a size. Scale attention reference before assignment. Oh yeah. What did it output for the function? I think it was just the scale. I think it was the output. Output. Yeah. I thought so. What did I possibly mess up here? Let's check this. Because I don't know if I need brackets around this. I don't think I do. Let's double check. Torch tensor. What do we call this? We call it triple out. It's the last size. Yeah, it's a tensor of 80. Size 0. All right, now we have output of the attention. Where was our master output? This will be the thing that contains everything. It's all going in this class here. Triple expert network. We'll call it quadruple. Quad expert. I don't like the ring of that. The quad network. The quad. Okay. So we want attention inside of this because everything ends up in here. So we will define attention above it. And then declare the attention inside of it. Four heads will always be the same, but embed size I guess I'll leave it at 80. Hidden size, output size. Is output size. What is that? Of course, Yeah. Output size. In case we want to change the output of these, it'll be there. So less hard-coded or double defining things, only having them defined once. Here. And we don't need this. Can I do that? Let's see. No. Object must be instance or subtype. Oh yeah. Let's pass something through it. Oh, I deleted that. Data loader. While I'm up here, clean up this junk. Okay. This is our X input. Oh, what is attention out not defined? Of course it's not. Yeah. All right. See where we are so far. By this, I'm sorry if I'm cutting off the screen. I like to have the screen at this bottom here so you can see what I'm typing into the prompt. But this is the output from our network so far. The quad network. The 9 networks, which are in the 3 mixture of experts. and then that goes through the attention, which is here. And now we're getting back to just the one tensor. Let me see, somehow I lost the drawing. It's a beautiful diagram. So copy this input tensor 9 times, input it into the 3 MOEs with the 3 networks. Those have 3 outputs. Those went through the attention, and now we're down to this one tensor again. This is the one here. It's been a little compressed on the feature side. And then this is going to be copied 3 times. It's going to be output through a final expert layer, mixture of experts. And let's do that by implementing this same thing, but now we're going to use this model, the network, which has a little more, one more layer. So we're going to implement it with that. But in order to do that, let me see where I define this. Here, when I initialize this, I want to pass this expert mid in here. Expert model. Let's continue with the lowercase. Expert model will be inputted as another input. And then where I defined it here, we'll pass it. And here, let's double check that. Why not? What's the issue? Non-default argument follows default argument. Sure it does. Non-default argument follows default argument. It is a, does it want it over here? Would that be better? Okay. Int is not callable. Is it an int? No, yeah. Do we also need to pass it through this one? Maybe. Right. Embedding size must be 0. Uh-huh. Right. Of course, I don't define it here. I'm putting it through a class, which is bringing it to that other class. I need to put it here. This expert model will go here. Oh, that worked. Now when I define this again, next time, how will I pass the other model in here? Probably somehow mixture of expert, mid, expert, end. Can we just define the mixture of experts without it being a big deal? We're going to need expert model 1 and expert model 2, maybe. Final expert. Expert model mid. And expert model final. Almost lines up. Yeah, it does. This is a really recursive rabbit hole. Classes. This is going to take the expert model and I don't think it's going to take quite the same. Because what is this getting? It's input size will be the output size because we are taking the output and putting it in the input. What do we want for a hidden size? Something reasonable. Something like, I don't know. We're going a little longer, so not quite as many neurons, but more than enough, maybe 180. And our output size will be 1. Is any of this going to work? Oh. How did this work when it wasn't even self-attention? That could be a problem. Betting Medolo for heads. And I need to pass this now. Even though it is not implemented yet. Our final layer, that is. Okay, attention works. It was working the whole time. And now the final expert takes attention as its input. The final output, the y-hat. Of course there's an error. Okay, 180, 536. 180, 180. Output is the input, right? Oh no? What? Repeated output size. Of course I did. Input size is output size. Yeah. I did repeat the output size. I'm just going to need to make the input size 80. Y does 15,360 become the output? It's a bit complicated in here. Let's take it outside. See if we're working again without it. No. Let's call that this. Up. Wow. This is a class. Wait, isn't it? Yeah. Yes, it's a class. But does it need to be yeah? No. Final expert. So we'll see if it's a problem with this tangled web of imports or these parameters themselves are the problem. Mixture of experts. 80 hidden 180 output. Although, why wouldn't this be our input size if the output from the attention is 80? The input size should be 80. What is the I don't know. Why would it be not taking that? What do you think? Input dim. Oh, duh. Did you see what I did there? This has to be the same as this. This has to be the same as this. This is how the linear layers, you know what they do. This should probably, maybe, fix the issue. And our final output. This is going to be our prediction. Almost there. Let's see. Maybe the mean. Yeah. If we want to make this just one list of one array of 256 numbers, should we take the mean? Let me consult with the expert. I want this to be just, this is my output. This will be my y hat. The prediction, I want this just to be 256. What is the best way to do this with another layer and a transpose or something? Or should I take take a mean along that dim after squeezing. And squeezing would be if you wanted to squeeze this dimension, just removing it. Unsqueeze they call increasing the dimension. Appropriate method depends on your task. If one of the time steps is specifically meaningful for a prediction, you can select that time step. No, it's not. Wait, is it? No, I don't want that. This has no more, there's no more last time step using a linear layer. Oh, I can do this. Can I do that? I could just add this to the end of the final network. Maybe. Expert and object has no attribute linear. This is new. Triple mode 2 tensors. What do we do? Yeah. Oh dear. Yeah, this is throwing up. I probably didn't define it in the init function. It's a new layer. Wait. Darn you. Oh no. So I can't do that. Can I do it here? I mean, it is still the last layer. It didn't change anything. What? I have to rewrite this. Network. Right. So, yeah. What? Oh no. I vaguely remember, I don't really remember. My model is self-linear, assuming 60 time steps. No, yes. I don't know about the looks of this. I don't like it. The input has 60 time steps. I really don't know about that. Of course not. Of course that wouldn't work. Write this in a way that will work. Do I need a new network? You wouldn't believe how illiterate, backwards you can speak to this and it still understand. Oh, interesting. It's just about as ugly as I thought it would be. It's almost there, right? Like if you were talking to a person and you tried to put like a brutalist poem together, trying to verbalize something that you can barely verbalize to a person, they're not going to understand you. GPT-4 tends to understand everything, all your intentions. Don't need all that. It's a batch of 256 and sequence length of 60. See, if I was talking to you and you knew as little about what I'm doing as GPT-4 does right now, you wouldn't come up with all this stuff. Okay, output size times 60. Yeah. So what I'm doing right now, as I showed before, I would like to have just one dimensional, just like the number line, list of numbers, a number for every item in the batch, for the batch size, to use that as my prediction. I could take a mean, I could take just one of those values, but I would like for the network to narrow it down, get the neurons to do it. Neurons are smart. Although it might be having trouble with this, it doesn't always understand shapes. Same error. It's expecting a tensor of dimension 60. So I'm seeing the tensor being in shape. Yeah, this is the one thing you tend to see it get stuck in a loop. That's not right. Output size is 1. Yeah, it does tend to get in that shape. Maybe I should figure this out myself, because that's just a multiplication times 1. It's not taking in the batch size. So I had to hard code it in there, which is not ideal. It didn't work. Oh, but that was close. Is it this? Holy mackerel. Way off. Input size, output size, output size. And then I want to let's work right here. Let's set up shop right here. And equals these things are good to initialize with. No, we don't want that. We want the tension output. Oh. Although so this will be what's going into the final mixture of expert network. This is what's come out of the attention. And I never honestly quite understood exactly. I mean, kind of got a hint, knew about it a little bit tangentially. How these shapes work with the batch size. There's nothing about the batch size in here. It can take one, or it can take as many in the batch, and does not do any modification of the batch size, maybe even no modification to the feature. I think we need a new network, yeah. There's going to need to be a new network. It's just going to take in 60. output 1. Right? Single layer. And we could just put that in the quad. Maybe. I think so. We'll see. We're going to leave this alone. In, out. Go back to making this final output. Let's put a linear although this might need to be in a new class. Yeah. Let's try it. Input. Is that how we? What? Yeah, input hidden. So the hidden will be that. Right? What is this going to give us? The last layer is not defined. It doesn't. Doesn't. Final expert. That's the final expert. This needs to be self last layer. I might be getting a little loopy. I'll put final output squeeze. And all right, we did it. It's going to need another El Squeezo on the back end. And this is our output tensor. It's 256, as I wrote in here, 512. And I could easily make the batch size 512, or you can make it 32. Definitely something you want to adjust when you're doing your back testing. We did it. It's all complete from beginning to end. Copies it 9 times. And these 9 different networks are fairly independent. And then the experts, the mixture of expert models themselves are somewhat independent, focusing on different things. The query, the key, the value, this is an attention mechanism, self-attention. So it's aware of things that it is aware of. And I think this is the kind of model of the future, maybe. There's probably more to come from this. I arrived at the idea to take the output and put that as the input from one mixture of expert set of models to another, just because I was thinking about how neural networks are these things called perceptrons. And let's see, they are what the neural networks are comprised of. They've been around since, I believe it was the 50s, but people didn't stack them, concatenate them together, take the output from one and make them as the input from another until a few people, I think it might have been the 70s or 80s, when Geoffrey Hinton started, along with some others who may have done it before or in parallel, but it would make sense that that hierarchy and that complexity and compounding, which not only is it hierarchy and the compression in artificial intelligence is what makes it so intelligent, but also it's all of these random neurons in there being able to explore. So I'm sure others are having the idea, and we looked up on Bard earlier that there are some, and I'm going to train it here in a minute, and we did GPT4, I asked it didn't know about anyone else stacking these mixture of expert models. The Bard Google LLM did tell us there was one case of people stacking, but I don't know. I haven't seen anyone doing mixture of models in a row and a stack, and then going into an attention, and then the output of that is the input to another mixture. So we'll see if it works. We'll see if the gradients explode. Let me turn off this. Keep things bright. And now we can look at it here again. Now that it's defined again, these are our 3 expert models, mixture of experts, 9 networks in here, divided up 3 ways, 2 layers in those first ones. Here's our attention mechanism, then our final layer. That last feature is 80, then 180, 180, and output, which gets output over here. Which ends up compressing this down to 1. And instead of doing a mean, which ChatGPT might tell you to do, if you want to get this one prediction, I'd rather the neurons figure it out, the neurons here, so the neurons can decide which one through this long network, which to turn off or turn on. Although maybe someone has a better idea of how to do that. Maybe I should whittle it down a little more. But that's probably enough layers. Plenty of neurons here. If you were to multiply every one of these together, would be the number of neurons in the network. So enough chatter. Let's train this. Let me think about how I want to do that. not complicated. Write a training loop for the data set. Use Adam W and Adam W optimizer and what loss function do you recommend for what you see I've been working on. Use implement it with mixed precision, please. We're working on sequence prediction, time series similar task. MSE loss, mean squared error. Oh, I thought of it. Smooth L1 loss. Yeah, device. Looks good. I'm gonna need these. We still need to implement L1 and L2 regularization. That reminds me, I'd rather use L1 loss. I don't know if that's a spelling of L1. L1 loss. Right? L1 loss. And grad scalar more like 100 epochs. 1E4 is better. might need this more than once. We've got the to device here, as we showed in the beginning. Torch.cuda.is available equals true, and this is how you get your model and your data to go to the GPU rather than the CPU. And I like to keep this up here. Model is not defined, model is defined now. This seems redundant, and we know it's a training loop. And this also seems like a thing to have in an import block. I mean, what else is it going to be? So this is for stocks. I think when someone does end up, or maybe even banks and certain funds, maybe, I'm just totally guessing, I would guess are using something like this. When they do figure out, I would think there's a possible chance it might be something like this, something that is has the kind of features like GPT4, something really groundbreaking. I mean, I think this is on the right track. You might disagree. I've seen other architectures come and go. I think stuff like this might be, if it were possible for neural networks to do anything, have some kind of edge in the stock market, thinking, making their own, coming to their own thoughts, their own conclusions, that it would be something like this. What I'm getting to, why I'm on this jag, is because the issue has always been overfitting. So overfitting is still going to be a problem with this, and I want to ask GPT4 and Bard about regularization. I'm doing time series prediction and need to avoid overfitting. Would you suggest L1 and L2 regularization? I thought that was an A. Please add to the code. Oh. We need dropout layers. Yeah. We need to put dropout layers in between every, I'd say every layer within all of these networks. We're going to need dropout. So those are just things that selectively, randomly turn off certain neurons and force the network to look in other areas. Please add to the code. And when I say every neuron, I just mean that would only include this right here. Oh, right? You don't need dropout before and after the ReLU, do you? You know why I really, among many other reasons, these are so good for teaching is because you can ask it so many stupid questions. Like, you wouldn't, I don't know, email someone about some little topic like this. I mean, if you were going to school for this, you're in some track, getting a master's, getting a PhD, then you're going to be in your group with your other peers. You could ask them. Even these might be stupid questions. But you can ask these LLMs a million stupid questions, go very slow. Right, drop out. Oh yeah, just one dropout. Okay, if you drop out, we're going to crank it up to 5.5, I mean. Excellent. And then GPT4 was taking care of L1 and L2. How does this look? For time series task implementing regularization can help prevent overfitting. L2 is more common and is often referred to as weight decay. And the atom W optimizer you're using implements L2. You want to add L1, move, it's not built in. Include both L1 and L2 like this. So does that mean I don't need L2? L1 lambda, L2 reg. We're getting there. Almost there. Literally just about to press the training button. Real close. Right? Is it a train data loader? I don't think that's something we have. I think we have a data set. Normally you'd have the training set and then a validation set and a test set, but we're essentially going to download, just do an update of the CSV file, data frame we already have, which has the last 2 or so, 3 or so weeks updated. And the thing about this is, remember how the model is just returning that one tensor or that 1D array? So we're not going to be predicting multiple stocks. This network is not going to be committed to predicting more than just one of these stocks in that data frame we showed earlier. And it's not going to predict more than one value. But if you remember our y, which is of the two tensors, the tensor in the second position, this is our y, our actual. So what we want to do is to, in some way, bring this down to one value that encompasses everything that we want to predict in here. We'll do that by taking the mode, not the mean, not the median, not the average, but the mode, which is if you have a cluster, like the biggest cluster of points, let's say they're all right in this price area, even though you have one up here and one down there, that's going to factor into it. It's not a median, but it's going to be that figure that's more closer to where did most of the stocks go. And we might even want to reduce this number a bit. I think we really might want to do a strategy, especially for you youngins out there, or anyone who wants to spend more time on this. We have this one loss function here, the L1 loss. It's not a mean squared error loss. What you want to do is train it for a while on that one stock, possibly on this one loss with that one value. You can even reduce this, and essentially you're getting it to guess the next thing that's video has been about, looks like my video went out on myself for some reason. That's okay. But this is, if that's the case, we don't need it. But this has been a bit like what we know about GPT4 and models in general, ones that do really well. A way to harness the power, the innate thing that it learned within it, is to train the model to guess the next thing in the sequence. That's how these large language models work. Don't know that it would work with time series prediction. We're going to do our best to make sure it doesn't overfit. And really, it's just going to be one more possible thing for you to factor into your decisions, maybe, if you do want to trade. If you're taking enough precautions to do that, not doing it with a lot of money, but just to see how smart you are, have a impossible task to try to do. But anyway, you train a model to guess the next thing in the sequence, and then you train it again with another loss function. And that's something we might even do here if I feel up to it. You know, get GPT-4, ask it for a more exotic loss function, and get it to, you know, not to start from scratch, but to do a modification of the model that you already trained that picked up the knowledge by guessing the next thing in the sequence. When a model guesses the next thing in the sequence, in order for it to eventually start getting that right, it has to learn things about the data. It has to learn connections within the data to kind of build a representation of the world of that data in order to guess the next model. And if you want to copy from people who've done well, that's something that tends to work. So extrapolating from one to the next, like I said, can't make any promises that it's going to get you the Lambo, but it should work in many other tasks, work really well. What is with my video? Okay. Anyway, let's get back to that final bit. So let's take the mode on dim 1
get rid of this guy. Don't need that anymore. Mode on dim 1. How's this look? It doesn't have a shape. Huh. Oh, that's right. It returns to the mode and then the index that was the mode. That looks good. But we only want to predict one thing. And what do we want to predict? There happens to be a list of among these 267, and like I said, if you've climbed this peak with me, this mountain peak, this lower level, we have this model. I think it's promising. Definitely should work on some other tasks. Probably pretty powerful and efficient. These, I believe, are essentially, are they running in parallel or no? Does it do one and then compute the next and compute? I don't know about that. PyTorch tends to work on things behind the scenes to have them all running at once, but let's not speculate. But yeah, as I was saying, as you continue on with this project, there are many stocks, and if you find a combination, and oh, this is really good tidbit, actually, morsel of information, would be pairs trading different stocks within an industry. Like when, for example, Southwest Airlines goes up, there tends to be a relationship to that with other airlines like Delta. So you subtract, normalize, and then subtract one from the other. See if the subtraction of one normalized stock from the other is something that you can predict, along with combinations of other things. And that tends to be where quants tend to pick up some alpha. And so I've heard. But these tend to be pretty choppy. So let's train these, especially maybe just this one here. Let's do our index trick. It's a list. It's number 8. So what we want to do with this is taking number 8 work. Yes. So this will go into the actual. This is going to be our security, the index, because we not only have stocks, we have other things like oil and gold, which you would call a security. AEP, utility. All right. That might be ready to go. Data frame has no attribute column. Expected 3 got 2. Batch size, sequence, length. Where's that coming from? Model inputs. Inputs targets. Shift L to see these numbers. It has a problem with 20. That's the input. The model's defined. Oh, this might be deep. And mixture of experts forward. Okay, data loader, not data set. Tensor size 256, must match 267. Where? Right. What are we getting for outputs? Oh. Right. So this is not slicing. There we go. Yeah. This was just taking the wrong dimension. Probably a difference between horizontal and vertical. Scalar step optimizer. No if checks were recorded for this optimizer. I didn't know I needed checks. What could that mean? Is model not defined? Well enough? Oh yes. Maybe that wasn't redundant. Okay. That's a bit low to start with. And we don't have exploding gradients. It seems to be training right off the frickin' bat. That's pretty cool. What what could I do in the time being? Waiting for it to train. I could say we want it to keep training until it looks like it's starting to plateau. If it plateaus too much, we'll just start training it again. I worry that it's training so fast, it's probably overfitting. I might start increasing the L1, and it says L2 is built in. Increasing these in order to see how much they could be increased and still train. Dropout is pretty high. And something we could do, should do, especially since this is costing time in the cloud and costing you electricity, that you want to save the model not only for inference, but then save it again to train again. Train it with a even lower loss function, lower learning rate, but with a different loss function, maybe a loss function that's a little more exotic. A loss function, if you can figure out a good one that says, does the value that the model predicted, is that reached after something like 200 time steps? Even though the y-hat for this only has a small amount of time steps. 22 time steps, 22 5-minute increments. And what is that? About almost 2 hours. So I might think that it's learning something while it's predicting this mode, that is doing that by learning relationships between these when different combinations happen in certain ways. It's definitely taking all of those values in all at once every time. Not all of them, but 60 times this number of columns times the batch size, about 100 times. This looks like it's plateaued. Good timing there. Let's get the new data. I want to, let me move this, to use the Yahoo Finance Python API to get all the tickers in my list to be columns in a data frame. I want the data to begin I want the window of data to end today and begin 59 days ago. About 2 months is the limit on Yahoo Finance. There are different sites where you can pay to get more data. All right, columns in a data frame, that should be enough. Please and thank you. Okay. How about this? Here is our Yahoo Finance. Something you'll need to pip install if you don't have it already. Oh, we'll need that. Our tickers will be the list. Right? Something else holding us up? No. Because you usually see a progress bar. But while we're waiting on that, oh yeah. We have minute, day, week, month. Those are also in our column. Let's remove those. Get rid of those final 6 from our tickers. But we don't need to run this again. Okay, here is our more recent data. When did our last one end? Our last one ended on November 3rd. This one ends on December 11th. So we'll get to see the prediction. And let me get the chat bot to write the prediction. So it's going to do no grad and eval, which will turn off the workings for the gradients and things behind the scenes. For inputs and data device, looks good. This DF needs to be DF new. Every one of these needs to be changed. In this one selected cell from DF old to DF new. See if we have any issues making this. Of course, we wouldn't have a date time. Would we? No, it's already the index. No errors so far. And it's normalized. And what the heck happened to our time embeddings? Okay, it needed the date time column for that. So why don't we make a date time column and then delete a date time column? Because that's going to be easier than changing the function both for the old and for the new data. Oh no. There's definitely a, it's called data time. Okay, normalize, mean of 0, standard deviation of 1, has the time embeddings. What is wrong with minute and hour? Does that say 40 rows? Something went wrong. Very wrong. maybe we don't need these. Starting in October, oh, what? So this is not 5-minute data. Where did I get this? Yeah. That makes sense. That's why hour and minute would be missing. Stop that. Make this 5-minute data. It's returning daily data now. Okay. We can try to guess where this goes. No progress bar. Now we wait. I mean, what do you think it did? It had the dropout. We're just waiting on this star to change. Still waiting on that star. All right. Now we have plenty of rows. Enough that it will recognize data it has already seen. There we go. 3,084 rows. Every time embedding is there. And then this made something to evaluate our model with a few comments ago. Didn't it? Yeah. But We need our data loader. To be updated with df new, which is somewhere up here. Right. Not shuffled. Oh dear. Is this what worked last time? Yeah. Oh no. So for the inputs, what is the model output? I think it's still a batch, right? So we need to loop through the output. What does this extend? Move predictions to CPU to NumPy if needed. Yeah, it's needed. Yes, it's needed. But I believe an output is still a batch. What? Right? But I need the It's been a long day. Output, inputs, outputs. Do I not need to do for single out in outputs? Let's get rid of that. Okay. This is not a good model. It probably just did a linear regression fit. But let's reuse our check. I mean, I could learn it, but I could just ask ChatGPT. I used to know it. Oh, no, 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 no. 1970. What? Yeah, so the model overfit and it did a linear regression, it looks like. So let's train it for less. Less time. Oh, that's not what we wanted to do. how is it looking 10 epochs in? Which is not right because we're still training on the new data. We want to train on the old data. Yeah. Model inputs, inputs to device. Inputs. But, so there's not a problem with the prediction. Reconstruction. It's just the model is doing linear regression. Straight up. Yeah. I wonder why. Let's lower the dropout, see if that helps. Alright, dropouts cut in half, and let's make the data loader the set from the data that ended a few weeks ago. In fact, more than a month ago. AEP and maybe this is too high. We'll just take a little weight off, take a little load off the normalization. Up. So, what do you think? What do you want to hear about? What's interesting while we train again? What's in the news? Close that, close that. And so DF new. New data set. New data loader. Right. Oh, there we go. Huh. Oh, that's actually good. So if the... I hope it was worth it. We're 5 hours and 20 minutes in, and this looks pretty good. This looks really good. I might not publish this video because it's moving the right direction. It jumped up. The prediction didn't follow it. And it did not have to train long to do that. What I want to do next is iterate through all three of these. Let's try this with 27 epochs. Guess what I'm going to do now? Remember this, holding. So for ticker in holding, where was I defining security before? Now it's going to be brought up by the ticker, and then that is going to save a model here. Quad model. So these should train pretty quickly, right? And then I'm going to be able to load so why this is good, although it's pretty anecdotal, it's just a one-off, but our data probably ended sometime in here. If it's 2-month data, and that was almost a month ago that our data ended. Where's our, that's our new. Where does the old end? It's really in your way when you don't want to see it. Now I can't find it. So the old one ended in November 3rd. And this one goes past that more than 2 months, and this data from beginning to end is about 2 months. So sometime in here was where this prediction said it would be. I mean, it knew what was going on during this time, and from here on out is a prediction. And still some uncertainties, like the uncertainty would be, is it only making a prediction that's not too far away from the last value it has seen? Is that all that it's doing? It's just tracking. Although sometimes you will see a prediction that is far off, or a prediction will just level out and tend to stay the same while the stock is going way up or way down. And does that mean that it just is stuck in this stupid sideways movement, or is there something about the model and the relationships it learned in the data where it believes it should be in that zone, in that area, if it wasn't for some fluke or anomaly that's causing the stock to go in a different direction. And you don't know. So that's the kind of the uncertainty. And the way to really test this is not to do paper trading. That is not virtual trading with some virtual stocks. Open a virtual with an app or something. But the way to do it is to do it with give me 1 second. To do it with actual money, as small amount of money as you can, no leverage, and then to do it with market neutral, having as much long as you are short. That way, if any dramatic thing happens, you're protected when everything goes up, you're protected when everything goes down. If there's a surge, interest rate thing, Federal Reserve thing, crash in the market, financial crisis, what have you, then you're protected. And then also not to bet more than 1/15 of your bankroll, even if you have some super sentient psychic ability that you can predict the stock market 90% of the time. If you're going double or nothing every time, that 10% error rate statistically can still, well, maybe not 10%, but 20%. I mean, nobody does better than 55 or 60% in the stock market. So if you're all in, if you're doing double or nothing, it doesn't take more than a fairly short losing streak to wipe you out. Let's get this, as I'm looking at it, this should not be ending here. So we need to add a 60 to the beginning of the prediction. And we go to GPT4. Make the prediction plot start at 60 values on the x-axis instead of 0. Wasn't that our sequence length? Was 60? Right? Oh, no, no, no. Yeah, 60. Yes, yes, 60. Nice. Oh. Plot values for predictions. How's our training coming along? That's not a long training time, but there are lots of brains here in this network. Yeah, so from 144 to 60. Cost. We're about a little more than halfway. It has stored those and coming for these. So we want this to go in a loop. And then we'll load the plot. Yeah. Model will still be the model, and we'll just load this. Right. Now it's the quad model. And it's only 26 steps. Oh, I can't wait. Can't wait to see what it does. It's not going to be AEP every time. It's going to be the ticker, which is the ticker in holding. Grabs that ticker from the column. That's the security. The security selects the model. It plots what's going to be the figure size. Doesn't plot it, but that's the size it's going to plot. It takes this from the data. Doesn't matter if that's old or new. Wait, yes, it does matter. If it's new, that's the new data. So we can see that recent month, see how it did. And then we've added 60. Plus the length of the predictions. That doesn't look right. Where are our predictions? We still need that. Array. There we go. Progress. Oh yeah. So, any errors? Not too shabby. All right, that one was blown out. Intel, pretty good. Lin, I mean, these are not way off. I mean, this is still making predictions. This one is 2 months. Not 2 months, but from here to here is 2 months. And then this is where the model stopped making its predictions. So it had already seen this data, whether or not it recognized it. It's not way off. That ended up doing a linear regression for some reason. So this ended up being correct. I don't know, something must have hit Alibaba, some special news. Yeah, Amazon's not wrong. Not wrong, not wrong. And also trained some of them on 49 steps. Yeah, training too long just does linear regression. So how long should they be training? Should they train for 10 steps? How about 12? This will be fast. Yeah. What do you think? I mean, I didn't have it on screen for long. 26. And now it's 12. Almost done training. So I hope from the things that we've gone through, might be obvious what the possible things to try out in the future would be to change this sequence length. I would reduce this a little more and then train it a bit. It tends to really be overfitting, which is strange that when I increase the dropout, it's not Did I say overfitting? I mean, it's doing linear regression when I increase the dropout, but the model is training very quickly. And you would think with more dropout, it would generalize less, but work more to find a good solution. But I guess too much dropout is making it give up essentially and just do linear regression. But what I would do, plenty to adjust there, plenty of knobs, plenty of things to tweak. It's training so quickly, reducing the learning rate, increasing the elasticity, elastic net it's called, when you have L1 and L2 regularization. So maybe more of that. And lost my train of thought about the sequence length for the actual. The way that they trained GPT-4 and they're training these large language models is by getting it to predict the next word, and then after the model has done that, it's learned something about the world by being able to predict the next world. It's had to figure some things out about the data in order to do that. And then what you can do is fine-tune it. You can fine-tune it in a way by asking ChatGPT to give you some exotic loss function. What you could do as well is adjust it by hand by doing a reinforcement learning with human feedback. That's what they're doing with these large language models. A human will rate the output, which is something that humans can do with stocks. I don't have my good examples up here, but I think we're done training and I can put one up. It's a bit hard to get an equation to give you a good prediction for a stock. Oh. So this is giving me linear regression too. How did we even do that? How did we do the 26? At a training of 26, it was pretty good, right? Not bad. I mean, there's no glaring, aside from Alibaba, why is see, ChatGPT is not always up to date, but Bard does tend to be up to date. Why is Baba, the stock, sinking lately? And it'll know. Can you read that? There are multiple factors contributing to the recent decline of Alibaba. Macro industry headwinds, slowing economy in China. So maybe it's the entire Chinese stock market. Cancellation of cloud spinoff. Alibaba's decision to cancel the spinoff of its cloud computing unit, a potential high-growth business, disappointed investors. Who knows, really? Okay, downgrade. Who knows? Is there really? Sometimes there's a reason. Sometimes the reason that they give is the reason, but there's always some uncertainty. But this looks pretty good. I think this, aside from Alibaba and that one that overfit, I mean, it predicted that it would go down, and it eventually did. Nothing dramatic. I mean, I wish we would see something like this going up and then BABA spiking back upward to confirm. But you know what I'm going to do? I'm going to put this on up. Oh, I'm sorry about that. Yeah. If you see, yeah, like I would like to see Alibaba, if it spiked back up. But you're going to be face to face with randomness if you spend a lot of time doing this. Going to be very random. I mean, what am I trying to say? You're going to be trying to find patterns in randomness. So don't lose your mind. And whatever you do, don't lose all your money. Don't bet too much. But what I'm going to do is select, what should I select? As I said, I've been doing this for a little while as a hobby, so I have a few more. Let me try these 50 some. What did I change in here? That's what I changed. Okay, from 26 to the other one. You know, going the 26 epochs, I did change that, and that brought us back to linear regression. So now we're going to train on this big guy here. And what I'm going to do is pause recording. And then I will show you what these did. So we'll really get a good look at the stocks. But I don't know. I think a high learning rate might be pretty good, getting it to generalize a low amount of epochs might be good at getting it to generalize. But I'm going to pause it now. So what we went from 146 to 65. Yeah. Okay, we'll pick this up where we left off. These models on this array of different tickers.
I'll give my love to you, I'll offer it. You make me a man, girl, I'm loving it. I cannot figure out for one why you loving me, oh. But you make it worth the time we had to spend on you. And I want some words, I don't drive Bugatti, I don't rock Versace, yeah. She love me anyway. With you it all feels different, but I hope to God I'm right. Cause I ride for you, I die for you, gaga. The way that you walk, yeah, the way that you talk, got me yelling to what I am,
3/4 of one of these blocks here from here to here is about a week. So you might be waiting a week and then see it diverge again up here. Look back in hindsight chart. So this is the time when you want to sell short, and not this time to sell short, because it would have had pain here, and it would not have been at the
Playing with fire, running through the burning flame. You were
Once you
poison.
have the money,
Why you gotta fight me
hopefully not rich.
over every little freaking thing? You were toxic. I can't give you time no more.
You see, it's a little.
If you call my phone, I can't answer no more. Girl, I swear I'm better off without your laugh. If I roll the benzo, then you treat me special. Last time I tried, everything you said was a lie. You're not what they see when you smile.
Freshy.
Oh, when you smile. Oh, na na na. Oh, na na na. Oh, na na na. Oh, na na na.
Tuning.
Ah,
It really
girls in Miami
is here.
all have a thing in common. Ah, they all like to swing. Oh, they all love to swing.
Sold short.
Ah,
Ended up closing.
girls in Miami all have a thing in
Saved it.
common. They all like the ocean. Yeah, I just wanna show
Baba. Or something unpredictable. Worth asking if towards the middle is where I start seeing data that it hasn't seen before. Worth asking if it's better towards the beginning of
All I have mercy on
towards the
my
second half.
soul. I don't put up with a lot of this, yeah.
Good.
So I came up with a master plan.
Even still, it's doing
No more
like
should I, could I, would I, I'ma
still
do it,
almost
then
call
I
it
get it.
line. I mean, it's a good prediction. If it's not going through the
Lord have mercy, please.
like I was saying, if it's not going through the middle, it tends to be
Oh, nah,
running
nah.
through the top.
The last time I tried,
Then what else
my
can we
world
say
was a
about
hurricane.
most of
I
these-
tried to fit you
most of the
in
bets?
and you chose to run away. I'm fanning out the flame cause all you do is
Indicating
drain.
most of the time that it will go down. It seems like most of the time it's indicating that it is going to revert back within the trend. Like, even though it goes down, it's saying it's going to revert to what has been the trend back here. But I would think it's doing more than that because it's looking at the combination of all different 270 some columns in one. that was giving us a straight line prediction for everything, which was not good, so I put it back. And this was, all of these are the hyperparameters that we had almost from the beginning. You really need to worry about the secret getting out. I think even if this video gets a lot of views,